I was told to speak in English, but I hope it's okay to speak in Korean. Any special request? If not, I'll switch my language. 안녕하십니까?
Good afternoon, ladies and gentlemen. Today, I am going to present what was already proven and tested in the maritime sector, which is the nuclear power-based power production and generation for ships. First of all, I would like to explain the background and mandates for maritime nuclear sector. And centered around UNIST, Seoul National University, KAIST, and other industry participants have cooperated to develop MicroURANUS. I'm going to introduce to you MicroURANUS and our future plan. First of all, recently, SMR has become the buzzword across the world. In Europe's green taxonomy, many SMRs are likely to be included. For example, the fourth generation advanced reactors are getting great attention from many people. In May this year, the Korean president and the US president declared their plan for joint cooperation for this nuclear power. And in COP26 meeting last year, UN's Special Presidential Envoy, Mr. John Kerry, had a meeting with the European leaders and said that we have to achieve net zero by 2050. John Kerry also mentioned that as a solution to achieve net zero, nuclear power could be a candidate. As Professor Seo just mentioned, we are moving towards green shipping. 2 years ago, Clarkson's research reported that 67% of the vessels will be clean ships and 33% of the ships will be LNG-fueled vessels, and the rest will be diesel-based vessels. So diesel will gradually fade out. In just 2 years, there was the change in our target timeline to achieve net zero after COP26 meeting, and Europe and the US and other global leaders mentioned net zero shipping, and we expect that LNG fueled shipping will actually phase out earlier than we expect and move forward truly net zero shipping. For naval vessels, 700 small modular reactors types have been used. Most of them use pressurized water reactor just like Korea. 8 of the PWR have been in use for 80 years. They use the cooler as liquid lead. For these technologies, I'm going to share with you the current status and the future prospect. As a result of our study, we found that the lead cooling will be used more actively. Based on the Clarkson Research's 2021 data, by 2030, 2,000 new ships will be ordered. Among those ships, large vessels that are likely to use nuclear power amount to quite a large number. For example, systems like our MicroURANUS could be installed in the large vessels. From 50 to 80 megawatt electric power could be supplied by one MicroURANUS that we developed. During the whole life cycle, the nuclear installation requires large capacity, so we expect the operating period could be for up to 40 years. So if we compare nuclear power with diesel, LNG, green ammonia, nuclear power is much cheaper. Nuclear energy is half the price of diesel and 4 times or 5 times cheaper than green ammonia. So if we can have nuclear power globally accepted in the maritime sector, then the maritime and shipbuilding industries need to cooperate with each other and accelerate the adoption of nuclear power in shipping so that we can lead the future maritime and shipbuilding industry. Then what kind of mandate or requirements do we have? Unlike naval vessels, in the ocean, an ordinary ship is exposed to the risk of getting attacked by terrorists or pirates. So we need to solve the possibility that the nuclear power could be abused by terrorists, for example. And secondly, we need to think about the stability and safety if any accident takes place, like the Fukushima accident, and if the nuclear reactor melts down deep in the ocean, then what will happen? A large amount of radioactivity will pollute the ocean. And if we cannot take out the nuclear power fuel rod from the ocean, that will be a very big problem. And you also need to think about whether we have sufficient amount of uranium. What's important is that if we make a massive investment in the earlier phase, then it will be difficult for many industry participants to adopt nuclear power. So PEACE, peace, is the reason and or requirements we need to meet to adopt nuclear power in the shipping industry. First of all, in the case of safety issues, PWR is used the most for naval vessels or submarine vessels. And highly enriched uranium is used, and the fuel does not need to be replaced because it could be used for up to 40 years. For a commercial vessel, we can use a limited amount of enriched uranium. In the case of Russia, they have to replace the nuclear fuel every 5 to 7 years. Sometimes, actually, they replace the fuel at sea, and if they make just a little mistake, then nuclear explosion could take place. Actually, there was explosion during refueling process, and if you approach this in a very careful manner, you have to spend about 9 months for replacing the nuclear fuel. And if the ship faces an accident and sinks under the sea, and if the seawater permeates to the nuclear power system, then radioactivity could be polluting the ocean for a long period of time. In the case of Russian naval vessel, they use the nuclear fuel, which is based on the low enriched uranium, but that can be used for up to 40 years without the need of replacement. This is because it has high fuel efficiency. If the ship sinks under the ocean and if the lead becomes solidified, the nuclear fuel rod will be closed or sealed. And in the Kara Strait in the Arctic Ocean, Russia abandoned two vessels that used nuclear power. In the case of PWR, radioactivity is released faster, and it takes 30 years for the radioactivity to spread or increase in the ocean. And before the 30 years are reached, we can take some measures to minimize the impact of the radioactivity release. We conducted, actually, Leo Szilard conducted marathon project with Einstein in 1942. It came up with the idea for micro-lead fast reactor. And in Russia, they developed a nuclear power-fueled submarine. And after the war was ended, they constructed the terrestrial SMR, and Belgium and Italy and Westinghouse have developed and are now establishing terrestrial SMR. In order to meet the requirements of green taxonomy, we have to solve the issues related to the spent nuclear fuel. But these reactors can burn the spent fuel, so this SMR is ready to be included in the green taxonomy. And through the naval experience, we can learn that we can use micro-reactor for maritime applications. Micro-reactor has power output of less than 30 megawatt. And the equipment that refuel the nuclear vessels is quite large-sized. But in the case of micro-reactors, we can protect the physical nuclear security, and we can apply weld sealing or insulation to the head of the reactor so that it can prevent the proliferation risks. It can also prevent the abuse of the nuclear fuel by terrorists. This project we have been doing is to develop the SMR that could be used for a longer period of time. And we tuned various relevant technologies to develop the most optimal SMR. The blue one refers to the intensity of the flame, and PWR power output is the red graph. So whenever the red graph falls to the bottom, we have to replace the nuclear fuel. And lead has corrosiveness. So through joint cooperation with Europe, we developed the proper material that could prevent the corrosive problems of lead. And as I mentioned before, if there is any meltdown or explosion, then severe problems will take place. And in order to prevent such severe accident, we constructed the design in a way to prevent the massive explosion or leakage of radioactivity. The height of the MicroURANUS is 11 meters. If this is installed on ships, we can install 2 MicroURANUS. 16,000 TEU containers are our target. First of all, we are going to test this system on icebreakers. So by 2035, we will be able to develop the full MicroURANUS system targeting icebreakers. and there's a ever-increasing demand for hydrogen fuel, and Korea has to import most of the hydrogen fuel, which is expensive. But Korea is surrounded by the ocean, and we have to consider the bunkering. And many bunkering facilities exist on offshore. So we could first start constructing offshore hydrogen production project, just like the project that the Korea Maritime and Oceans University conducted, so that we can produce clean maritime hydrogen energy. So our MicroURANUS might be used as a fixed platform or floating platform for such facilities. In the suction file that use wind power, we can apply nuclear power, or we can install the system on the barge. So this is an idea to get hydrogen fuel at lower cost. The cost is estimated to be about 8,000 Korean won per kilogram, but if we use nuclear power, a MicroURANUS, we can reduce the cost to 2,000 Korean won per kilogram. This is our vision. First of all, we will focus on the vessels. This is so MicroURANUS system, if it uses lead for cooling the reactor, then the cask could be, the thickness of the cask could become thick. And we could install MicroURANUS with various automation technologies. We could test this at factories, and if the radioactivity release from the MicroURANUS system is not at a level that we should be concerned about, then it could be tested and built on vessels. So if we completely make the MicroURANUS, then we will have to install this on the ships for testing, and then we could receive the license. As Professor Kang-gi Lee said, we have to think about the life scale. Recently, a new scale SMR was listed, but the stock price is going down. The problem is related to the spent nuclear fuel and how they're going to dismantle the reactor. This problem was not solved. In our case, we will put the microreactor in the cask that is also used for carrying spent nuclear fuel. And we can reuse or recycle the casks. And as we develop MicroURANUS, we are considering various ways to reduce the cost for dismantling the reactor in the future. And International Maritime Organization will have to update the safety codes, and different countries, including the US, EU, and China, are establishing their own safety codes for such systems. And we need a certification system on such SMR reactor. And we also need to engage insurance companies in the development and certification and commercialization of the small modular reactor. By 2027, we are planning to get pre-license, and by 2031, we're trying to do the demonstration at an offshore hydrogen plant and have the actual ship, real ship trial after 2030. We're receiving support from the Ministry of Science and ICT and the Ministry of Oceans and Fisheries. Private companies are also participating in this project. So this is PPP partnership. Internet companies are also joining us in this project.
첫 번째 프로젝트는 하이드로젠.
Our first project, hydrogen. Second project for vessels.
이렇게 해서 다음에 혹시 유니스트에 오시면
If you come to UNIST next time, please visit our research center. And let's have more in-depth discussion about MicroURANUS. Thank you very much for your attention.
Thank you very much, Chair Professor Il Sun Huang, for your presentation.